Okay class, now we'll try to do another questions regarding your empirical and molecular formula. Okay, so the question said a hydrocarbon contains 85.7% carbon and 14.3% hydrogen. Okay, they have another information there. Relative molecular mass of this hydrocarbon is 70. Okay, so the first question is ask you about determine its empirical formula. So the key word here is empirical formula. So for you to find this empirical formula, you need to use the same step that I teach you just now. Remember, if they ask you to find empirical formula, means you need to use the same method, the table just now. Okay, so let's recap what you have learned in the previous video. You should have the table. Okay, so this table should have 4 rows. Okay, 1 2 3 and the last one is 4. So the first row element, second row is your mass, the third row is your mole, the last one is ratio mole. Okay, so now how many columns you should put depends on the questions. Okay, here in this question you have 2 elements only, so you should only add 2 more columns. Okay, 1 and 2. Okay, so the first element that you have from the question, you have element carbon and then you have element hydrogen. Okay, what is the mass of carbon? As you see in this question, they also didn't mention about mass. They give you the percentage, but as you learned just now, you can take the percentage as your mass. So it will be 85.7. Okay, so hydrogen will be 14.3. Okay, so next you need to find the mole. Remember which formula you should use. Okay, the informations that you have mass, so the formula that you should use, mole equals to mass over molar mass. Okay, so your mass equals to 85.7, your molar mass will be 12 based on your periodic table. Okay, so if you divide this, you will get 7.14. Okay, use the same technique for hydrogen. The mass, mole equals to mass 14.3, molar mass hydrogen is 1, so you will get 14.3. Now the ratio mole, remember we divide with the smallest mole. Now if you see here the smallest mole, of course clearly you see the smallest number is 7.14. So for the ratio mole, the mole which is 7.14 divided by smallest mole which is 7.14, it become 1. Okay, now for this one, the mole is 14.3 divided by smallest mole. If you see the smallest mole here is 7.14, you will get 2. Okay, so here the ratio is 1 and 2, so your empirical will be C1. I not need to write down 1. Okay, H you have 2, so this is your empirical formula. Okay, the same method. Now the new one for you is about molecular formula. Okay, this table is to use for empirical. For molecular formula, okay, the formula that you can use is this one. M in bracket empirical times N equals to molecular formula. Okay. Okay, this is the formula you can use. Very simple formula. Now, first what you need to do, you need to find the N. What is N? N is a constant, a number. So, empirical you already determined just now. The symbol is CH2. Okay, so put in bracket times with N molecular formula. As you read in the question just now, they doesn't have any information about molecular formula except they stated that relative molecular mass. Okay, molecular mass here is 70. So what you understand by 70? 70 is mass for molecule. It's stated in the question. Relative molecular mass is 70. So 70 is your mass of molecular. Okay. So here the formula said molecular formula. You don't know the formula, but what you know about them is their molecular mass. As mentioned in the question just now, the molecular mass is 70. So here I put 70. Okay, so for the empirical, you can determine the mass of empirical. You see that for empirical you have CH2. So you can find this mass by, as you check in periodic table, carbon is 12 plus with 2 hydrogen, which is 2 times 1 because hydrogen is 1, times with N, you get 70. Okay, so if you continue, you will get 12 plus 2 is 14. 14 times N, you get 14N equals to 70. And you find N, and you will get 5. Okay, so your N is 5. So what you should do with your N5? You substitute back the N here. Okay, put back N here. So you will get CH2 times 5. Right. So if you times, actually the formula will be C5H10. So this is your molecular formula. Okay, so that is the technique. Okay, I hope you can understand how to find the molecular formula.